Welcome to today's explainer. So, artificial intelligence is literally everywhere right now, but honestly, it's so easy to get totally lost in all the buzzwords. To make sense of it all, it really helps to picture a Matryoshka doll. You know, those wooden Russian nesting dolls? You open the biggest one, and there's a smaller one inside, and an even smaller one inside that. Well, that is exactly how AI works. We've got these layers like machine learning, deep learning, and generative AI, all nested neatly inside one another. Think about the mechanics of your own daily routine for a second. How does your phone automatically unlock just because you looked at it? Or how does Google Maps predict your arrival time with such crazy accuracy? We rely on these systems all day, every day, but we rarely stop to peek under the hood, right? Today, we're going to map out exactly how these nested layers actually function. Here is our roadmap for today. 1. What is artificial intelligence? 2. How machine learning works. 3. 3 types of ML. 4. Deep learning and neural networks. And finally, 5. Generative AI and NLP. All right, let's dive right into this and open that outermost layer of our doll. Part 1. What exactly is artificial intelligence? At its absolute core, artificial intelligence is simply technology that allows systems to perform tasks that would normally require, well, a human. As people, we're naturally pretty great at recognizing patterns, understanding speech, and analyzing what we see. AI is just about getting machines to do exactly that. Take automated traffic systems, for example. Instead of a human standing on the street corner squinting at license plates, an AI system analyzes a live video feed, detects the plate of a speeding car, reads the numbers, and automatically issues a ticket. It's directly replicating human visual analysis. Moving right along to our first subset, Part 2. How machine learning works. So, traditional computer programming has a pretty major limitation. A human programmer has to explicitly write out every single rule. You give the computer an input plus the hard-coded logic, and it spits out an output. Machine learning flips this entirely on its head, and it's a real game changer. With ML, you give the computer the inputs and the outputs, and the machine figures out the logic all by itself. Instead of us painstakingly hard-coding the rules, algorithms dynamically learn from past data to generate their own logic. And at logic, that is what we call a model. Now, this self-learning happens in 2 distinct steps. Step 1 is training. Imagine a bank trying to decide who gets a loan. They take thousands of past applications, those are the inputs, like credit scores, alongside the outputs, meaning whether those loans were historically approved or rejected. The machine studies all of this to build its logic. Then comes step 2, inference. When a brand new customer walks in the door, the machine uses that trained logic to make a prediction on whether to approve or reject them. It learned how to make that decision entirely on its own. Let's go one layer deeper. Part 3, the 3 types of ML. So, machine learning isn't just one single trick. First off, we have supervised learning, which is trained using beautifully organized, labeled data. Think of how Gmail sorts your inbox. It was trained on thousands of emails explicitly labeled as spam or not spam, so it knows exactly what red flags to look for. Second is unsupervised learning. This is where we throw a massive, messy pile of raw, unlabeled data at the model and basically say, hey, find some hidden structures in this. If you feed it thousands of random news articles, it can automatically cluster them into neat categories like tech, sports, and politics without any human help. And then we have the third type. Type number 3 is reinforcement learning. And the intuition here is actually exactly how you'd train a new puppy. If you tell your dog to sit and they sit, you give them a reward. If they don't, they get nothing or maybe a mild penalty. Reinforcement learning applies this exact same psychology to AI models, teaching them to make a whole sequence of decisions in really dynamic environments. Here is how the mechanics actually play out. You have the model acting as an agent within an environment. When it takes a good action, it gets a positive reward. When it messes up, it gets a penalty. The agent's singular, driving goal is to maximize its total rewards over time. If an AI is learning to play a game like snakes and ladders, hitting a ladder gives a mathematical reward, while landing on a snake issues a penalty. Through literally millions of trial and error attempts, it maps out the absolute optimal path to win. And honestly, this exact reward and penalty framework is the very thing that allows a self-driving car to safely navigate a super busy city street. Opening our next nesting doll now, Part 4. Deep learning and neural networks. You might be wondering, why do we even need a deeper layer? Well, traditional ML eventually hits a brick wall when it deals with messy, unstructured data. It is fantastic at structured data, things that fit neatly into rows and columns, like a clean Excel spreadsheet of loan applicants. But if you feed it unstructured data, like a raw audio file or a massive grid of pixels in a high-res photograph, those millions of simultaneous data points totally overwhelm standard algorithms. For that, we need a completely different architecture.
Enter neural networks. These are the absolute core of deep learning. They're actually inspired by the neurons in the human brain, and they feature an input layer that takes in all that raw, unstructured data. Then you have multiple hidden layers sandwiched right in the middle that crunch and process all that information. Finally, an output layer delivers the prediction. But it begs the question, how exactly do these hidden layers learn anything?
The underlying logic here is surprisingly intuitive. Think back to college and how a professor calculates your final CGPA by assigning different weights to different exams. Midterms might be worth 30%, class tests 30%, and the final exam 40%. Now, if students stop showing up to class, the professor might adjust those weights, maybe making class tests worth a lot more to force a change in behavior, right? Neural networks do the exact same thing. Data moves forward through the network to make a guess. If that guess is wrong, the network calculates its loss, moves backward, and meticulously adjusts the mathematical weights of its internal connections. It's essentially learning from its mistakes, fine-tuning its own grading rubric until its predictions are spot on. Now, because unstructured data varies so wildly, we rely on a matrix of different deep learning architectures. Feed-forward neural networks handle straightforward, one-way data. Recurrent neural networks have built-in memory, making them perfect for things like sequential text or stock prices where past context actually matters. Then we have convolutional neural networks. These are the heavy lifters for images and video, scanning tiny patches of pixels to find edges and shapes. And finally, transformers. These use incredibly powerful attention mechanisms to process massive amounts of contextual data all at once. And that brings us to the final, innermost all, Part 5, Generative AI and NLP. Up until now, AI has basically been playing detective, analyzing, categorizing, predicting. But generative AI shifts from predicting the known to generating the entirely new. This is the specific subdomain powering the modern tools we use to create. It's the magic engine behind GitHub Copilot generating whole new blocks of software code, or OpenAI's Sora creating hyper-realistic videos from just a simple text prompt. When it comes to generating text specifically, GenAI relies on two interlocking engines. First up is NLP, or natural language processing. This is the field dedicated to helping machines actually interpret and generate human languages, complete with all our weird context and nuance. The second engine is the LLM, or large language model. These are massive deep learning models, usually built on that transformer architecture we just talked about, that are trained on just vast swaths of internet text. They are the actual brains predicting language patterns to write your essays, answer your emails, or brainstorm ideas with you. So, looking at your own daily life and your specific profession, which subset of AI do you think will impact your career the most over the next 5 years? Will it be machine learning's precise predictions, deep learning's complex analysis, or generative AI's creative power? It's definitely something to think about. Thanks for joining me on this explainer, and I'll catch you in the next one.